Okay, in this video we're going to be looking at trigonometry. This is trigonometry. This is for your CCA A21 module. The first bit of this is really just a recap of what we have done in last year when we were looking at our AS1. So first thing is a couple of formulas which we should know from last year. If you've got sine and cos, your basic trig functions, two most basic trig functions, then the next most basic one is tan, and how you get tan is sine divided by cos. And also you've got this very important connection formula between sine and cos, which is sine squared theta plus cos squared theta equals 1. So this relationship between the two of those as well. So you've got tan is equal to sine divided by cos, and sine squared plus cos squared equals 1. Right, to solve a trig equation, we're going to use what's called the cast diagram method. I'm going to ignore all this at the minute, and we're just going to talk through it, how we use this method here. So first example says solve sine x equals 0.8, and that is for 0 is less than or equal to x is less than or equal to 360 degrees. Okay, if you didn't put this upper limit on this 360 degrees, so it was just to infinity, there would be an infinite number of times that some value of x would give sine x equal to 0.8. But within our range, from within a 0 to 360 or one full revolution, whatever way you want to look at it, there's generally going to be two solutions. Okay, so why this is, if I just do a diagram here to show I'll be getting around this in a second. There's my sine graph from 0 to 360 degrees. There's 360, there's 180, and there's 0. So 0.8, if we had 0.8 here, you could go across, and there's going to be two times two x values, this x value here, and this x value here. Two x values that would give you sine x is equal to 0.8. Okay, using this graph in this form is a very bad way of doing it. So we have a much better way of doing it. I'm going to leave this here just to show us that our answers will make sense when we finally get our answers. Okay, to do this then, apologies. Okay, so to do this, first thing we want to do is do BA. Now what BA stands for is basic angle. This will be in the notes up above if you read through those again. So basic angle. How you get the basic angle, I'm going to just say, I wouldn't normally write this in, but this is just for the sake of your notes. It is sine to the minus 1 of 0.8. Okay, so it's the inverse sine of whatever you've got over here. And just be clear on that, it is, you make that thing positive. So in the next example, it's going to be a negative thing. So you'd ignore the negative and you just do sine to the minus 1 of whatever the numerical value of this thing is, so 0.8 in this case. So when I did that to one decimal place, I got 53.1 degrees. Okay, now we draw what is called our cast diagram, and this thing is a brilliant bit of mathematics here really to get this. It's class, so it works really, really well. Our basic angle is 53.1, so 53.1 goes in here, and 53.1 goes in here, and I'm going to label this, just for the sake of this one, I label it 0 degrees, 90 degrees, 180 degrees, 270 degrees, and 360 degrees. So you should have seen your cast diagrams before. I'm going to go through quickly what's going on here. Okay, your cast diagram, why it's called a cast diagram, first of all, starting in the bottom right, you have C, then you have A, then you have S, and then you have T. So it spells out the word cast, C-A-S and T. And also have we look at how the degrees go. They go from 0 to 90 to 180 to 370 to 360. So it goes, for the positive ones, it goes anti-clockwise. Right. Now, our sine x was equal to positive 0.8, so that means it goes in here, because in this quadrant, S, which stands for sine, is positive, and also A, which stands for all, is positive. So here, your sine is positive, and sine is positive in these two positions, where sine is positive and where all, or where everything is positive. C stands for cos being positive, T stands for tan being positive. So in this quadrant, cos is positive, In this quadrant, all three of them, sine, cos, and tan, are positive. In this quadrant, only sine are positive. And in this quadrant, only tan are positive. Now let's just look back at our graph. This was our sine graph over here. And notice for the sine graph, sine was positive between 0 and 180 degrees. And sure enough here, sine is positive from 0 to 90. And sine is also positive from 90 to 180. Then sine would be negative from 180 to 270. And sine is only tan's positive. That means sine must be negative between 180 and 270. And likewise from 270 to 360, sine is negative. And from 270 to 360, cos is negative. So cos is positive, which means sine must be negative. Okay, how we actually use our cast diagram. We're just going to say x equals, so this is our solution. And we're going from 0. So the first angle I come to is 53.1 degrees. And the second angle I come to is 53.1 degrees away from 180 degrees, which is 126.9 degrees. So notice when you put your basic angle in, it always goes with the horizontal line. And you can see it's from the horizontal axis. And there's my angle, 53.1, and the horizontal axis, there's my angle in here. And that's it. Okay, that's our first example done. Okay, in this next example, there's a couple of things which are a bit different. The first thing is that my angles are not in degrees. I'm using radians in this case. So I'm just going to draw, before I get started doing anything, I'm going to draw my radians axis. So it's 0, and instead of 90 degrees, it's going to be pi over 2. Instead of 180 degrees, it's going to be pi. Then 270 would be 3 pi over 2, and 360 would be 2 pi. So again, same idea as before. When you're going positive, the positive way, you're going anti-clockwise. Okay, in this example, you've got to do your basic angle. Now, this is where people make their first mistake in these things. So BA, your basic angle. How you get your basic angle is you do cos to the minus 1 of 0.5. You ignore the negative sign up here. You ignore it. And it's just cos to the minus 1 of 0.5. So you do on your calculator cos to the minus 1 of 0.5. Calculator into radians mode first of all. So into radians mode, and then cos to the minus 1 of 0.5. Press equals, and I've got a third pi, and I'm just going to write that as pi over 3. Okay, what I had failed to write on my cast diagram was my letters. Very important: C, A, S, and T. Now remember, we are talking about cos here, and our cos was negative. So cos is positive in the C and in the A quadrant. So it's negative in the S and the T. So this is actually where our angle pi over 3 needs to go this time. So you do your line going this way, you go your line going this way, and your pi over 3 goes in here, your pi over 3 goes in here, and that's what you've got. Okay, the first angle you come to from 0 all the way around to here. So the first angle, x is going to be, that's pi minus pi over 3, which is going to be 2 pi over 3. And my next angle is going to be all the way around to here. So that's going to be pi plus pi over 3. So that's going to be 1 and 1/3 pi. So, or nicer to write it as 4 pi over 3. And that is it. Okay. Okay, this is an extra example which is not in your notes, just to show you a slightly different version with variation here that can happen, which will appear in this exercise. So in this one, you've got to solve 2x equals 0.5, and that's for minus 180 is less than or equal to x is less than 180. Okay, first thing you want to do is your basic angle. So your basic angle, and how you get your basic angle, it's cos to the minus 1 of 0.5, and which is going to be cos to the minus 1 of 0.5, which is going to be 60 degrees. Okay, so we're in degrees in this question again. Right, now the problem with this one is this bit, my angle is not 2x, so you've got to double your range. So you've got x here, it doubles and it becomes 2x, and that means the range also doubles. So instead of minus 180, it's minus 360, and then the other way it's going to be positive 360. So I wouldn't normally do out two cast diagrams, but I'm going to do it for the sake of it in this question. So I'm going to do the 0, the 90, the 180, the 270, and the 360. And I'm going to have another one over here, which is going to be 0, but we're going back the way this time. So minus 90, minus 180, minus 270, and minus 360. And we had our basic angle of 60 degrees, and cos was positive, so it goes in here in the old one, and here in the C one, sorry. So that's 60 degrees and 60 degrees. Same over here. I keep forgetting to write in my C, A, S, and T. So it goes in here where cos is positive, and it goes in here where cos is positive, and then we're good to go. Okay, so for the positive one, you're going anti-clockwise to get round to your angles. So this angle would be 60 degrees, and this angle all the way around to here would be 300 degrees. So far I've got x is equal to 60 degrees. Sorry, I haven't got x. I've got 2x equals 60 degrees, and 2x equals 300 degrees. Over on this one, we're going back the way. So it's going to be minus 60 degrees. So this angle is actually minus 60 degrees. And this angle over here is going to be minus 300 all the way around. So I have my minus 60 degrees, and I have my minus 300 degrees. Okay, your last thing for you to do then is to divide by 2. So that was what 2x was equal to. That's what x is now equal to 30 degrees, 150 degrees, and minus 30 degrees, and minus 150 degrees, and that's us done. Okay, just have a look, just check. All of my angles, 30, 150, minus 30, minus 150, they're all in the original range, so that's a good thing just to check at the end. Okay, one extra example is if you've got one like this, where you've got sine squared plus cos plus 1 equals 0. Now the problem here lies because you've got sine squared and you've got cos's, you have two different kind of things. So what you want to do is use this identity we had over here. I'll just put this. We had sine squared x plus cos squared x equals 1, which means sine squared x is the same as 1 minus cos squared x. So what we want to redo is rewrite your original equation. So it is 1 minus cos squared x plus cos x plus 1 is equal to 0. Okay, so now this equation is all in terms of the one thing. It's all in terms of cos. So we'll tidy it up as a wee bit of a mess. What I'm actually going to do is bring it over to the other side. I hate the quadratic term being negative, so I'll bring it over to the other side. So cos squared x minus cos x minus 2. And then we'll go ahead and solve this. So I don't know if this one will solve particularly well, to be honest. We'll have a look, go and see. I haven't actually worked this one out. Let's have a look and see. My sum is minus 1. My product is minus 2. Oh, it is going to work out all right, actually. So minus 2 is equal to minus 2 times 1. So we know how to rewrite our thing. It's going to be cos squared x minus 2 cos x plus cos x plus 1. Then factorize the first two terms completely. Cos x can pull outside, leaving you cos x minus 2. And, oh, something's gone wrong here. What have I done wrong here? I'll just pause this for a second. Apologies, see my mistake here. This was 2, minus 2, sorry. I've written it as positive 1 here. So this is why set your work out well. You should be able to see your own mistake. So I'll change that back. That was a minus 2. And so I factorize my first two terms. I factorize my second two terms. I can pull a 1 outside. That's cos x minus 2. Now I know I'm on the right track. I've got the same common bracket. So cos x minus 2 upon cos x plus 1. Okay, I will scoot down a little bit and see. That means cos x equals 2, or over here, that means cos x equals minus 1. Now, this happens quite a lot. This was by fluke, it happened in this example, but it does happen quite a lot like this. In this case, cos x equals 2 is impossible because cos can only go from 1 to -1. So just write down IMP, impossible, and then that's it. Okay, now this one, cos x is equal to -1. Now it is worth your while to remember, learn off where cos is equal to 1. So here's my x, my y axis. Cos is equal to 1 at 0. So that's where cos is. So, and there's your 0. I'm just going to mark on my my axis what is 0, 90, 180 degrees, and then that's me minus 90, and that's me minus 180 degrees, because remember where our what our axis was. It was what our range was, I should say. Minus 180 degrees is less than or equal to x is less than 180. So I know that cos is equal to 1 at 0. So it's going to cos is going to be equal to -1 in the opposite place. So it's going to be over here. So my answer for this one, that there's two values at work, which are going to be 180 degrees and minus 180 degrees would work for me here. You can check that if you want. You can put that into your calculator. Do sine of 180 and then square whatever you get as your answer, and then plus cos of 180 and then plus 1, and you will get 0. Likewise, do sine of minus 180 degrees, square whatever you get, then do plus cos of minus 180 and plus 1, and you will get 0, and it does work. Okay, folks, you're now ready to do topic 5, exercise 1, questions 1, 2, and 3.